All right, so this lecture is just going to go over a review of the test questions, if there were any questions on that. So feel free to post in chat or even unmute yourself and mention a specific question, and I'm be more than happy to go over it a bit more in detail if you have any questions on those. And if there are no questions, then we can move into the second half this week, talking about the Unity navigation system. None from Logan, and all right. So taking a look at the navigation system, there are several assignments that kind of walk you through how to set it up a little bit. So I'm going to basically do something a little bit different than those assignments and kind of walk you through a little bit of a different setup so you can see it a couple of different ways. So right here is the sample scene that we were playing with on Monday. So this was just going over a little bit of a dictionary setup as well as just basic scripting review. So what I'm going to do is actually disable those scripts, and we'll be basically building a little bit of a navigation system in here. So for this, we need some sort of gameplay level. Right now, it's just got camera and light in it. We will need to add a new object, and I believe it wants you to set up a terrain. So we'll go ahead and do that as well. Now, the terrain itself, with it selected, we can change its different settings over here. And here's where we can actually set how big it is and how long it is and stuff like that. We'll drop this down since 1,000 is quite big. We'll just say 50, even like 20 would be plenty for just a quick demonstration. So 20 by 20 is a much better gameplay area to work with. And then we'll also just make sure it is at 0, 0, 0. And I'm going to actually offset it to -10, so it's got the center of the terrain right in the center of the world. So -10 in the X and Z. And I'm going to change our camera to be, instead of way over at the side or such a big angle, I'm going to set it up so it's a top-down camera. So I'm going to push it up in the level a bit more. I'm going to go up to about 7. I'm going to get it centered on that terrain, so 0 for positions, Z and X. And I'm going to rotate it around its right axis so that it's facing straight down. So a 90-degree rotation gets that camera pointing straight down at the ground. Next up, we're going to need something to move around on this terrain. For that, we can create a simple capsule. We'll rename this to player. I want it to be on the level itself. So once again, we'll zero out the X and Z. As far as the position, I don't want it necessarily 0, that's inside the terrain there. So we'll push it up just 1.5 meters, no, just 1 meters, or 1 foot, since Unity uses feet. And we have this to play around with. Won't do anything because we haven't added any scripts to it or anything like that. First thing we'll want to do is actually add a component. There's a few different components when working with navigation. There's one called nav mesh agent. This is what you would put to actually use the nav mesh. Then there's nav mesh obstacles and stuff like that. We're just going to focus on the agent today. So got the nav mesh agent script or component attached. We can then add another script. We're just going to be creating a new script for this, and we'll call this our NPC, or let's go simple nav. So we can take a look at how we can issue this nav mesh agent component commands. We can open that up. And if I try and just immediately say like a git component and try and get access to that nav mesh agent component, if I try and type nav mesh agent, it's going to complain that it doesn't know what it is. Reason for that is because all the navigation stuff is stored in a namespace. So like we have these namespaces up here for some common ones, they try and wrap up all the navigation stuff into its own namespace. And we can use the IDE to actually find that namespace itself. We can show potential fixes, and it says, oh, we found it in this unityengine.ai namespace. Did you mean to put that using statement? Yes, we did. And now it knows what the nav mesh agent is. So that's very similar to if you have any buttons or anything like that, you have to do the unityengine.ui for button interfaces and text interfaces, stuff like that. And from this, we can actually call functions. So let's say straight from the start, there's a set destination, which is going to be our main thing to actually get our agent moving. And you can specify just a vector3 of a position where you want it to move to. So let's say we want it to move kind of towards the edge. So 10 in, or we'll just say a new vector3 here. Vector3, and we'll say 10 in the X, 0 in the Y, and 10 in the Z as well. So it should be moving to one of the corners of our map. Then save this. And back to our level. If we try and play this, we see we're getting an error, as well as a warning because there is no valid nav mesh. So in order to actually have our nav agent use a nav mesh, we have to bake the nav mesh first. That's actually up here through the window category. Under AI, there's a lot of options here, so don't get confused. We want the navigation one. We'll open that up. And this is where you can actually define what types of agents you'll have, the different types of areas you have, if it's walkable, if it's not walkable, if you can jump over that area, or if you could have swimming and add any custom types that you'd like. Then we also have the Bake tab and an Object tab. Object allows us to actually click on these different objects and specify whether they're a static object, whether that area is walkable, or stuff like that. So we see our terrain, we do want that walkable. We can then go to our Bake tab, and we want to make sure our agents are actually set. And we can just make sure that that is set to walkable. We'll click on, these are actually going to filter the scene over here. And we see it is set, but our bake is not quite letting us bake. So let's try and change this to not walkable. And it's not letting us actually bake this nav mesh yet. So with the terrain selected, I'm going to go back to our inspector and make sure that it does have everything all set. It does have a terrain collider. All right. I can't bake because I was playing. That's why. Whoops. So yeah, you can't be playing when you go to bake. So now that we're not playing, bake is perfectly fine. Was worried there for a moment. But we click bake and we see it generate the nav mesh around here. You'll see it doesn't quite get to the edge, and that is because we've defined that our agents have a width of 0.5. So we don't necessarily want our agents navigating to these points right here. That'd be half hanging off that edge and would look kind of crummy. So it can automatically calculate that radius right here. If we said our agents were a full 1 thick and we bake that, we'll see it pull away from the edge even farther and stuff. So we'll leave it at 0.5. But just wanted to show a couple of those options. You can change the height as well. So if you have some things in your level like a ramp going up and you don't want it to try and cross under the ramp before it can cross through, you can just adjust all the agent stuff right here. So now that we do have an agent or the nav mesh built, when we try and play, we see it's already moving. So just by setting that destination, it'll try and get to a point where it was at. If we look at it and check out our position, we see it didn't quite make it to the edge, and that is once again because the agent does have width and can't go all the way to that very corner. So even though the point that we were specifying was 1010, it'll try and get to the closest point on the nav mesh according to what you pass in here. So if we wanted to add some obstacles now, so we know it's navigating towards this corner, we could go ahead and add another, let's just go with a cube and drop that cube down, make the cube fatter and taller, so it's more like a wall. Then we'll rotate this around and push that a bit closer. So if we just press play now, we'll see our nav agent walk straight through the wall. So that's something you have to take into account. Anytime you're actually modifying the level itself or level geometry, you're going to want to rebake that nav mesh because our nav mesh still thinks it can walk right there. So this object itself, well, we could even leave it as walkable. That's perfectly fine. We'll watch what happens there. And now it just calculated the nav mesh around that edge. So when it goes to navigate to that point, it'll have to walk through these triangles to get to it. One other thing while you're in this view, if we select one of the things that has a nav agent component on it, we get the ability to adjust specific agent options. So we can see what nodes it's actually looking through. We can see what its current path polygons are. We're not running, so we don't see any of that debug stuff. But if we press play and pause real quick, we actually see the point it's trying to reach is right there, and then it calculates this as the destination point, as well as we get this red arrow going from our characters or the nav mesh agent all the way to that point. So when you are taking screenshots for these assignments, make sure that you can see this. If you can't and you had the player selected and stuff like that, make sure that you use that pause button while it is navigating. It's very important that we actually see that path when you are taking a screenshot for these. And if this agent display doesn't pop up, for example, if I try and play again, and pause, we see that that agent display just disappeared from our scene. If we need to bring that back up, we have to select another object and click on player again to make sure that those path polygons are showing and that it shows that actual path. All right. And moving on, if we wanted to go a little bit more advanced than this, and if we wanted, let's say, a separate character to actually call our nav agent over, and naming this player is probably not a good thing, but we'll change that up in a moment. So we would want some sort of player that we can control just using some simple WASDA movement. I'm going to remove the simple nav from this, since I'm going to create a separate NPC that'll have that, as well as the nav mesh agent. And we're going to take a look at how we can just get a simple character moving around our level, and then we'll also look at how we can get our NPC, and this will be our player. We'll create another NPC in a moment. So for a player, we need some sort of player script. There's a few different ways you can set up a player controller. You've seen several different ways of using rigid bodies and stuff. One thing I do want to point you towards is that they have a character controller for some simple movement already set up. This character controller comes with its own collider. So I'm going to actually get rid of the capsule collider from this, since this one already has a capsule collider set up on it. Then we can add a new script, and we'll just call this one player controller. Well, we'll just go player. So we created the script, open that up, and we're going to need a reference to that player controller, just like you would start the game with if you're doing a rigid body, you want to capture that in a variable for easy use. So we'll create a character controller variable here, the type name, and we'll just call it CC for simplicity's sake. And we're going to initialize it to a null value. We then want to actually, once the game started, get the component from our current game object. So we'll say CC, instead of just always staying null, we're going to set it equal to get component of type. And we're going to look for that character controller component on the same game object that this script is attached to. Once we have that, we can then start using it. There's a few things we're going to need to do for that. We're going to need to capture the inputs, figure out if they're pressing W, S, A, or D, and we're going to capture those into a movement direction vector. So we're going to create a new vector3, and we're just going to call this move dir. We'll initialize it to a 0 vector. Then in update, we can check the inputs and change movement direction based on which button we're pressing. So we'll say move dir equals, and we'll look at our input system for this. Get axis. There's already 2 axes set up for us. There's one called vertical for W and S, and one called horizontal for A and D. So we're going to be looking for that vertical. And we're going to multiply this by our current forward direction. So from our transform, we'll get our forward. We then want to add in the horizontal movement so that we can have at least 4 directional movement, or 8 directional technically. So instead of just doing an assignment, we're going to do a plus equals because we want to keep that forward movement in there. We're just adding on to it. We'll get the axis, and we'll look for horizontal this time. And instead of using the forward direction, we'll say this is going to be in the direction of our right vector. So we've got which direction we want to move. We're also going to want something to specify how fast we're moving and stuff like that. So we'll go ahead and let's make this one a serialized field variable so that we can change it in the editor. And we'll just use a float for our speed. I'm going to just initialize that to 5. 5 units per second is usually a pretty good speed, so we'll just use that for now. We can then tell our character controller to move using that. There's a couple of movement options. There's a move, which moves based on exact distances that you pass in, or there's one called simple move, which moves it based on a speed passed in. So we'll use simple move. And we got to pass in a vector 3 for this. Well, that'll be our movement direction scaled by our speed. All right. Let's save this. And we should be able to test this out. We press play, click in the game window, and we have our character moving. So that's fine, but our camera is not following along with our player. Typically in a top-down game or something, you have the camera focused on the player, or at least focused on the entire game area and stuff. If I want my camera to just follow my player directly, I can attach it as a child. So now my camera is going to inherit any movement that our player does. So now we can move around our game scene like that. And we can even fall off and then continuously fall forever. But that's enough for that. So we've got a character that we can move around. We then need to set up our NPC. So initially I had that attached to our player. Let's just set up another one. We'll be setting up another capsule. I'm going to drop it to 1 so that it's out of the ground but is touching that ground. And I'm going to also create another just simple material for that so that we can have a different color for it. And let's call this red. Change the albedo over to a red. And we'll apply it to our NPC, just so it's easier to tell them apart in the scene and game views. All right, so our NPC is currently just called Capsule. Give them a proper name of NPC. This one will be using our simple nav component. And that's that script we first wrote, as well as we'll need a nav mesh agent on here. And nav mesh agent does have a lot of options. I'll let you play around with them a bit. In particular, the speed, angle speed, acceleration, and stopping distance are the main ones that you're going to want to play around with. You will eventually, and when you're working on Sneaky Sneaky, might want to take a look at the obstacle avoidance depending on how tightly you have your quarters and things like that. So right now, if we just press play, that nav agent should just be still going to that corner because we haven't added any other functionality to it. So let's go ahead and change that up a bit. In here, we'll go over to our simple nav, which is on our NPC. Instead of saying move to that specific location, or that hard-coded location, we'll get a reference to our actual player object. So let's add a player reference in here. And we'll call it just P for simplicity's sake. And we'll set it to null at the beginning. And once the game starts, we'll grab that from the game. We don't necessarily want to try get component because our NPCs don't have this component attached to them. But we can do something called find object of type. And we can search for any player types. And then in update, so this is going to be running every frame. I'm going to add something so that we'll check for an input to be pressed. We'll say if input, get key down, key code, and we'll be looking for the space button to be pressed at this time. So when we press space, we will tell our nav agent to navigate to its position. So So just like we did with our character, I'm going to add a reference to our nav mesh component, or nav mesh agent component rather. And we'll just call this nav for short. Initialize it to null. And here we need to set it to an actual instance of the component. So we'll say nav equals, and this will be directly on the same game object. So we'll just be using get component. And we're looking for our nav mesh agent. And then we can use that inside our update. We can say nav, set your destination, and we can set it to our player objects transform.position. So it's always going to try and get to the center of our character when we press space. So we save this. And while we're playing, won't do anything. I can use WASDA to move around. And then when I press space, it'll start navigating towards me and even the exact position. So it'll push me out of my current position so that it can be where I was. And it will navigate around, finding the shortest path. And as we press space more, it can continuously follow us if we keep pressing that space and stuff like that. So that's just a little bit about the nav agents. One other thing I do want to point out, let's duplicate this. And we'll rotate that as well. We'll go to our navigation, and if we try and bake this, we'll see that it does even use ramps and stuff. We see that our nav agent can go up an angle about 45 degrees according to this. So if we run up that ramp and we press space, our nav agent will also follow. If we run over to the other side of the ramp and press space, it'll have to go down and try and go around that edge and just barely make it. So it does take into account that height, as I mentioned earlier, and will automatically calculate what areas are walkable, even if we add this ramp up to a second level. It would consider areas under the ramp or something like that if we really extend this out. And we'll move it like that and bake that. We see that this entire area is walkable as well as on the area above it. So it is full 3D when it is calculating the navigation. And if we, for example, get our nav agent way up here, almost ran off the edge there. And so I just press space at the top of the ramp, so he'll be going to that position. And if I then tell him to come back down the ramp, he'll just always go wherever I press that space, if he can reach it. All right. So are there any questions about the nav agent? Big one to remember is anytime you make any edits to like level geometry and stuff, you do need to rebake the nav mesh. And very important that when you go to access any of these navigation components, such as nav mesh agent, you do have the using directive in there. Okay. So the next part, the very end of this week, if you have two NPCs that have various radii, So you can specify different radius types and different bake types for the different agents. So for example, if we just have the one agent type right here, if we were to add another agent and not playing, so I should be able to just add that new agent. Oh, and can change the name right here. We'll call this one wide. We'll bump that up to, let's say, 1. So it is a lot wider. If we go over to the bake, we'll see that the bake settings are just going to use that default bake stuff. But if we add in this other agent type, there are ways to select the different bake settings and stuff like that. We could widen this up so the general nav mesh is perfectly fine. Let's actually just duplicate our agent and go back to the inspector and tell them that we will use the wide one. And we can open our agent settings. And we have wide selected right here. And our bake settings, we do have to bake it separately than that. And so baking is a bit odd. I don't really have a good answer for you on that one, sorry. I know there is a way to bake multiple nav meshes so that it does use one for one type and then another for another type. I cannot remember it off the top of my head. I'm sorry on that one. My best suggestion is just go for your widest agent when you are doing the original bake. Awesome. Were there any other questions about any of the settings that we have? Yep. Alrighty. So the next part that we're going to talk about today, it's not on GitHub. Is we just kind of talked about the navigation system. This also has you walk through it and then submit a picture for this. This is your first submission section where you do have to take a screenshot. While you are submitting that, it's very important that you go through the checklist at the bottom of the experiment. And way down. So right here at the submission, you are graded based on how many of these you complete, and there will be points off for if you miss one of these. Biggest thing is make sure that it is running. That way we know, like, a lot of these will not even show up if it's not running. So make sure it is running, that you have the layout correct. You may need to change it up from your normal workflow, or just so that you can capture everything. So like I have the scene, the game, the inspector. I'd probably even put my navigation tab down below. So, and make sure that you are laying it out how it asks, just so that you can see everything, have the certain things selected and stuff. And keep in mind that that pause button is your friend, because a lot of the things will start moving as soon as you press play. And if we pause, oh, and I had the two agents on top of each other. And we want to see this NPC's selection. We have to actually select it over in the hierarchy before it'll show its path. So just a thing to keep an eye out for when you are submitting that picture of them actually navigating through the points. And as I mentioned, next up is going to be the introduction to the state machines. So you'll watch a pre-recorded lecture for the state pattern itself, and then experiment 2 actually provides you with a state machine that this one is not the one that we provide the state. Sorry, jumping ahead to next week's stuff. This one just goes over kind of different state machines and what those are. I'm glad to hear it. Yeah, you'll be using AI quite a bit in the next few courses when you get to your final project to try and get some basic enemies and challenges for the players and stuff like that. Sent 2 screenshots, didn't catch the first one. Yes, yeah, you're more than welcome to fix any screenshots that you have issues with. Just make sure that it has everything that's needed. So this one just basically introduces you to the idea of state machines, and we'll set up a lamp. This one does not have a turn-in, and this one's just for your reference. While you are working through this, it's very important to kind of, it'll just have all these code snippets. It is up to you to figure out where they go in the code, whether they should be in the start, whether they should be at that class level, whether they should be their own separate class, as well as when you are working through this, it will have you replace some of the code you've written before, because it goes through a couple of different steps of setting up the state machine and then converting it to be a more elegant solution. So you will be replacing some of the code that you initially wrote. For example, they have you set up like an enum or something at the beginning, and then swap the states based off of that. And then later on, they take a look at the action delegates so that it can swap as needed and just invoke the current state rather than doing an if check and stuff like that. So this will be your first insight at how to change in between. This one also is intentionally using some old references. For example, accessing a light can no longer be accessed by just .light from a game object. The reason for that is so that you get used to watching some errors pop up inside Visual Studio. So if we do like game object, well, let's do lowercase g for our current game object. And if we do light here, and if we say, well, let's actually just kind of copy that same line. Enabled equals true. Enabled equals true. If we compile here, Control-Shift-B again, if you're in Visual Studio only. And, oh, and Unity also recognized that we're using an old API. Do you want to try and fix that? I'm going to say no thanks so that we can watch error in Visual Studio itself. And right here, it's saying it's obsolete. Property light's been deprecated. Use get component light instead. So this is just a way of trying to point you out that errors, while you may get errors, they don't necessarily have to be the end of that. Or if you are using an older reference, don't be afraid of them. Just take a look at what the error is telling you. It's telling you the exact answer of how to properly get the light component in the newer API. So there will be a few of those while you are working through this LAMP assignment. And then you'll have a quick test kind of on how the state machines are set up, just seeing some basic questions on how that's functioning. And they are all answered throughout the lecture as well as the experiment. So please use those as reference while working through that. Other than that, that's about it for this entire week. And we'll be catching back up on Monday for week 2 content. Were there any last minute questions before I stop recording? All right, I'm going to go ahead and stop the recording.